Okay, this is TempleOS 5-minute random code walkthrough, episode 20, and I'm your host, Terry Davis. So let's see where God sends us. Alt-B. Oh, we went to a song. Okay, another song. Now, I forgot to mention, the first line of the song is a comment. That's for... if you'll notice the jukebox, it has a number and it has a color, and the number is supposed to be a rating on from 0 to 9, and the color is graphics, words, nothing, incomplete, or special. So this song is let's see, what is this song? This song is Keeping. Okay, so let's play this song, see how it sounds. Keeping, 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 keeping. There it is. Okay. Okay, so it sets a drawback or a callback that gets called 30 times a second, and it rotates the heart 2.2 radians. In the Z is the axis that comes out of the screen. If the beat is more than 26, that means about 4 beats per measure. So we're looking at 6.5 measures. That's when the heart appears, and it scales. The heart beats, and there's a matrix to do a rotation, and it's a transformation. A transformation is a name of is a name for multiplying by a matrix. Anyway, to make a long story short, when we draw this sprite, it calls, if it has transformation, then it multiplies by the matrix R. If you look on a CDC, then there's a 4x4 matrix R. It happens to be fixed point. Its floating point is slower than integer multiplication. So anyway, the matrix is scaled. The decimal point is 32 bits. The matrix is I64R. It's 4x4, and the okay, so a 3x3 is how you rotate. The 4x4 is a little trick that's used to include a translation, which is rotating is rotating, translating is shifting by an offset. And if we have a vector here, our x, y, z, if we put a 1 here, then when you rotate, you take this column 1 times row 1, then it's x plus this last column here. This is x offset, y offset, z offset. So this is a trick I learned in a graphics class. So now the rotation, if you put a 1 in this position, then when you multiply, it adds an offset. And the nice thing is we can, let's just do a test. We can do a rotation in the let's rotate about the y-axis after we rotate about the z-axis. And the value, so these are applied after each other, one after the other. And if you have that offset, then that gets combined into one operation. Let's say sine of dt. So we're gonna rotate about the y-axis. Now let's see what this looks like. Oops. Oh, it only appears for a couple seconds. Okay, you saw that, didn't you? Anyway, so that's how that works.